enough to worry about as it is. So all of a sudden get overwhelmed with all this. Just want to take you to sit down and I guess memorize the domain, the range on those inverses. I'd be very, very, very careful with them. Basically, my inverses are done. This one was very unusual, where I could not find the answer directly. I had to turn to one of the trig identities or formulas. Sine squared plus cosine squared equal 1, and dealt with it like that. And in June, she checked it for me, and sure enough, by calculator, it checks. So sometimes I have to do that. Now, I may, as I race, on the new, and the three lessons are close by, the month is closed down here. Did I have maybe more inverses there mentioned? We can't do all of them, but we've already done some. On the new page, yeah, the new page, was there inverses of section 6162 listed again?
No, but in 6.2, there's one more.
Oh, on the previous page?
Yes.
Thank you, let me get that out of the way. Let's see what's going on here. Let's see if I can. Read that last one to me. We'll get that out of the way right now. Cosecant? Okay.
Tangent
Inverse tan.
minus
Negative 2?
Yeah.
Okay. So let's do this. Now keep in mind, and that's the last I'll do, guys, just want to take a little input from you, a little work there. This means, it does translate, it means this, there's an angle out there whose tangent is negative 2. And if you base it on the unit circle, I have no clue. It's not one of those on the unit circle. Like June gave me that crazy angle here. Who on earth would think of this? Where was it? 19.47 degrees. Who on earth would think of that? No one. So here's another one. They give me, which is not one of those that you are accustomed to from that unit circle. Does anyone have an idea? Now, I might approach this, but they will cosecant, even though I have no idea what size the angle is. We'll close down with that for inverses. That's what you think. Is there a property or identity out there that might connect and let me find what they want, because they want cosecant?
Cosecant is along the way what the sine,
Okay, from the side here.
just in case.
Exactly, okay, it's unique, cosecant is one of the side.
Tangent is sine over cosine.
Well, now, I'll take that, which is true.
Which means that sine is wide bigger than cosine or negative.
Oh, now you're gonna try to reason through that. But what you give me on the board right now is true, 100% true. Keep in mind, guys, this is another one, like that one over there, that you could not find directly yourself. Okay, that you may have used formulas or identities. Now, can anyone come up with, he's giving me a couple of hints here. Can anyone come up with maybe a formula of some sort that will sort of connect these two in some fashion? And then we'll try to find the answer, and then I'll have June check it for you. That's what we're supposed to do. And I'm talking about sine squared plus cosine squared equal 1. 1 plus tan squared equals secant squared. Do you remember all those identities? If there's one out there, maybe I can use it.
Cosine squared plus 1 divided by sine squared.
Oh,
plus
no,
1 equals minus 2.
no, I'm just talking about the basic. I think I gave you 6 or 7 or 8, maybe 6 or 7 of those. Just basic one. Sine squared plus cosine squared equal 1. Tangent equal to sine over cosine. Just a basic one. Yes.
1 plus tangent squared.
What do we get? 1 plus
1 plus tangent squared.
equals.
Secant.
Now, let's see if I can use it. 1 plus tan squared, which is true though, you know, is equal to what? Secant squared?
Yeah.
100%. I agree. And I know what tan is. Tan is negative 2. That's what this means. So Could I put a -2 here with what she gave me? It's gonna be squared. Lena, maybe, we'll find, see what happens here. Guys, is that 5 altogether here? Arithmetic on the left-hand side. Okay. Do a square root. With her help. And guys, right now I'm gonna write this plus or minus, because it might be a negative here, we'll check and see. And this is secant. Work with. Woo! I agree 100%. Now keep in mind, if they were asking me to find, Alina, I love this. If they were asking me to find secant rather than cosecant out front here, I'd be finished.
Cosecant is 1 minus.
I have to determine which one of those. Now, gotta go a little further, exactly. So now since I know what secant is, let's slow down and see if it's gonna be a plus or a minus. Guys, they gave me tan theta is equal to a -2. This is inverse. The restriction on inverse, darn it, these restrictions. Was it, help me out, caught between this and this? We did before the break the inverse tan, was it? So that means you're either in quadrant 1 or quadrant 4. They say tan is -2. Is tan negative in quadrant 1? No, everything's positive in quadrant 1. So where's this angle located? In quadrant 4. So this will help me determine what sign to use. So I'm in quadrant 4 based on this, not quadrant 1. Somewhere down here, where my signs are what? Positive, negative. Is that true? And right now, if you place y over x, a negative over a positive, does that tell me my answer should be negative? Okay, hang on. So here, and secant is negative. I'm in quadrant 4, I gotta be careful here. That's tangent. Yeah, of course, they gave me tangent to be negative. Now, how about secant in quadrant 4? If I'm in quadrant 4, secant is 1 over x. What's the x down here? Positive, so it's 1 over a positive, so that says, oh, good. She's giving me a positive radical 5, 1 over x, not negative. True? Gotta do a little bit of thinking on this. Now we're not quite finished. Alina, I wish, darn it, look at this. I wish it had been secant. And then we would be finished. We got the answer. Yeah, we gotta use another, identity, because they want cosecant. Now, can I pick up with what she gave me and go a little further and do something else and finally get cosecant?
Cotangent
Give me more.
equals
That's not cotangent what?
square.
Squared equals what?
Cosecant square.
Look at that. I'm gonna try that one and see if that's any better. We'll find what I need here. Here we go. 1 plus, now they want cotangent. I know what tangent is. Do I have replacement for cotangent?
1/4.
Should that be the reciprocal? Is -1/2? Are cotangent and tangent reciprocals one another? So if they give me that, his cotangent is the reciprocal -1/2, so it's squared. In fact, he's already told me it's 1/4. Oh, this is wild stuff. You guys agree? Tan was this, therefore cotan has to be -1/2, the reciprocal. Of course, it's being squared in the identity. So I got 1 plus 1/4 equals this. Wow. What is that, 5 over 4? Crazy. Do a square root.
5 plus minus 5.
Well, what's radical 5 over 2, right?
Yes.
And then I have to determine myself, with your help, look at this, you guys follow this pretty well for this to be that difficult. Cosecant, we're down in quadrant 4. Cosecant is what, 1 over y. Is y negative down here? So am I going to the negative answer? 1 over y for cosecant, and therefore it should be prefixed with negative. And that's what they want cosecant. June, hang on. When she checks this on the calculator, if this doesn't check, oh my goodness. Does all that rationale make sense? As you're sitting there in your mind trying to put all these little factors together and trying to come up with something. Yes?
Why, okay, where did the 1/2 come from, -1/2?
They gave us 10 is -2.
Okay,
And my little identity they give me to use has cotan, and cotan is the reciprocal of that.
And then also, why didn't we use cosecant theta equals 1 over sine theta?
Oh, he mentioned that earlier, and actually I did not have enough to use it, I got you. I just jotted down what he wanted me to maybe think about.
Okay.
It didn't help. So nothing does, it's just a true statement. He gave me. That's a true statement.
Thank you.
Alina gave me a good start, I wish I hadn't been secant, we'd been finished now. Now I know it's a cosecant and it's a negative answer. Now, June, to close this down, this is madness. This is one time you gotta get your act together and think through this. June, could you tell the class, because I have no idea, do an inverse tan on -2 and tell me its size. What size angle is that?
In degrees,
Yeah, do it in degrees, please.
it's 63.43.
43. Who on earth walks around and knows that? I'm sure there are some people who do that. Just walk up here and say, what's the inverse tan on -2? Or what angle are you talking about? Oh, I'm talking about 63.43 degrees. Okay. Now, where did we say the angle is located? Fourth quadrant. Now, I
Oh,
could be check
actually-
here. Oh,
I'm sorry, it's negative 63 point.
it's how much now?
Negative.
Oh, negative. Now, that takes me down to quadrant 4 then. Thank you, Jim. Now, help me out. Would you now find cosecant of that and see what that answer is, or approximately?
It's negative 1.118.
1/8?
118, yeah.
Something like that. Now, we got this answer. Approximate radical 5 over 2, I know it's gonna be negative. Find radical 5 and divide by 2 and see what that's close to.
It's also negative 1.118.
A negative 1.118, close to it?
Yeah.
That makes me feel better. She says my answer agrees with what the calculator answered. Hey guys, I can get a sense, I can look at you and I say, whoa, yes, this is going to hit you hard if we do not keep her act together. Who on earth would think we start out with inverses? That's hard enough, PK. Then all of a sudden, you say, Professor, I have to go back to one of these? That was another section, previous section. I did. I can go back to one of these. Finish it up. Okay, now this one right here, I love that Alina gave me this. It's just so I didn't take me to where I want to go. It took me to see it. But they wanted cosecant, and we finally had to use this one. Okay. Make sense, guys? Just gotta put the pieces together there. Now, Irina, on the new handout, all that about the inverses we'll skip, because I think I just repeat. Go to 6.3 and see what am I asking in 6.3. Okay, hang on now. That's what I'm going to do here right now. Arenas, race, how many examples do I have there?
6.
Whoa, 6 to work? Hang on, we'll work all 6, I doubt it. Okay, guys, we'll call this part 1. Here we go. And she says it's solving equations, I think. Arena, tell me what the first one is.
Cosine beta equals 1 over 2.
It's equal to 1 over 2. And was there a restriction on where I should look for the answer? Okay, no restriction. Now guys, this one is directly on the unit circle. Where have you seen cosine? And by the way, she says it's open, Professor. Does not have an inverse notation on it. I don't see a superscript -1, so no restrictions. You can name all of them. Okay, I heard pi over 6. Hang on now. Directly from the unit circle. I don't think it's pi over 6.
5 over 3.
Pi over 3. We all get those mixed up. All of us. Pi over 3, and since I'm allowed to use everything, is there another one? It's gonna be a positive one now. 2 pi over 3 is wrong quadrant. That's negative. How much was it? 7 pi over 3,
Five pi over
5 pi.
Five.
Is 5 pi over 3? That's true, guys, are those both positive? You check out the unit circle? I think the other two that you were almost making were negative. They want a positive one here. Joseph? Now, here's the problem, that's the reason I placed this on the handout. They said to name all. That means that if you stop here at pi over 3, which I think is how much, 300 degrees? Is it 300? Go another cycle. And pick up 2 more, then do another cycle, and pick up 2 more, and it goes on and on and on and on. They want all the answers. So can anyone tell me at this point what would be a good way to show? And by the way, does anyone know what the next one would be? Look at this is a visual here. I'm at 5 pi over 3, that's 300 degrees, quadrant 4, like that. And they're saying don't stop there. Do another cycle and pick these up again. So PK, that says don't stop there, go through and pick up, what was it, 5 or 3, and come down here and pick this up again. And then do it again, and again. Now what would be a good way to name all those, I'm not going to actually individually list them, it'll take forever. What would be a good way to represent them? Who has an idea? Theta is equal to? I see pi over 3 is my initial. And how can I get back to it? Another cycle, that would be 2 pi.
Plus 2.
Plus how much?
2 pi.
2 pi how many times?
Okay.
K. You can do it as many times as you wish. And again, remember K is an element of the integers. That will repeat that, pi over 3, as many times as you wish. How am I gonna get to the 5 pi over 3?
Plus 2 people. 5 feet.
Will it repeat also every time you go around? 2 pi? Any number of times you wish. K is an element of the integers, and those are called general solutions, guys. This picks up all of them. Okay. Now, June's been helping me out. I'm gonna ask you, she's taking beautiful notes back there. I'm gonna ask her to do me a favor. If these are correct, let's go to maybe this one. Let me just choose at random a K. And I can pick any integer. Let me pick up, choose one crazy one. Let's say that K be 42. If K is 42, 2 pi times 42, what is that, 84? 84 pi. Oh my Lord. Right, 84 pi? That's it, right? Randomly I chose 42. Okay. Then the angle would look like this, pi over 3 plus, what did I say it was again? 84? Was it 84? Pi. If I put that together, the common denominator of 3, this is crazy. Pi plus how much, guys, if I use a common denominator, I gotta multiply that by 3. How much? 2 something. 252? Oh, okay, it is. Thank you. Over 3. Arena has given me this pi plus, Jesus, got a pi here. Yes. And if I put those together, what is that, 253 pi? Madness. Is that true? Now put those two together correctly with the common denominator? Okay. Oh my goodness. I hate to ask you to do it, June, but I need to check this. This is not how it works. Would you please find cosine of that strange angle for me and see what the calculator shows?
Um, 0.5.
0.5? 1 half. Okay, now this, the way we wrote this up, you may replace K by E work, it's gonna give you 1/2, you take cosine. And that's what they want, it's called a general solution. Now, Rena, I don't know how much I'm gonna get down here, I'm gonna move to something else here shortly, but tell me, is there another equation to be solved? What does it say?
Cosine delta,
Inside? Okay.
equals 1/2.
Is it one over two?
1/2.
Like-
And there's restrictions.
Oh, there's some restrictions, what's the restrictions?
Delta, more than, more or
Oh,
equal
yeah.
to 0.
Oh, it's less than zero?
More or equal to 0 and less than 2 pi.
Whoa, I'm trying to think of how it looks. It's right, written like this,
Yes,
and then 2 pi?
yes,
Okay.
but without equal, not equal to 2 pi.
2 pi's not included.
Yes.
Looks good?
Yes.
Gotcha. Now they're putting a restriction on us. They don't want all of them, Phil. They just want the ones caught between 0 and 2 pi, which is 1 revolution. Guys, be careful. Cosine theta is equal to 1/2. We answered that back here. PK? I thought we already answered this. That problem looks so much like this. What's the difference? This says find cosine of what over here? 2 theta. This was just theta. It's not quite the same. So what am I gonna do? I'm say, hang on. We already found 1/2, so this 2 theta must be representing those we've already found, pi over 3, or the earlier, plus 2 pi k. We'll make it look nice here. Or 2 theta, that we found earlier, must be representing 5 pi over 3, plus 2 pi k, where k is an element of the integers. You guys agree with that? To connect these two problems? So this inside here, right here, must be representing these to make this work. And then you gotta solve for theta. Divide by 2, here goes. Divide by 2 or take 1/2, and I think this becomes pi over 6, do nothing mess up. 2's cancel here, just pi k. That's division by 2, that's one general solution. Down here, divide by 2 or take 1/2, I think this becomes 5 pi over 6. 2's cancel, pi k, and k is the element of the integers. Wow. And those are my general solutions. I mean, everything. Okay, I'm gonna ask June to do me another favor. Big up today. June, I'm gonna try, oh my goodness, let's try this one. At random, I'm gonna choose k to be some integer. Let me use some crazy number. I'm gonna let k be, before I give a big number though. If I let k be 0, guys, let me do it right now. Let's try some small ones first. If I let k be 0, this term drops out and leaves me for a possible answer, what, pi over 6. So theta is gonna be pi over 6. I'm gonna let k be 1. I'll let k be 1 here, this becomes pi. And if you add these up to the common denominator of 6, is that 7 pi over 6? I hope. These are particular solutions. We'll try one more. Try 2. If I put a 2 in there, this becomes 2 pi. Pi over 6 plus 2 pi, common denominator, is it 13 pi over 6? I think. Can you do it? I hope not. I hope I didn't make a mistake. And it goes on forever. Now, Rita says, Professor, they don't want all of them this time. They want only the ones caught between 0 and 2 pi.
One, sir.
So which ones should I accept here? In fact, I've listed some here. What should I accept? Pi over 6, 7 pi over 6, 13 pi over 6?
Only the first.
Can I accept this one?
Yes.
This caught between 0 and 360? Can I accept this one? Oh, wait, who knows the size of this angle here?
It's,
What is 7 pi over 6?
it's a little bit over than just 180.
Is it 210? Is it 210? Does 210 fall between 0 and 360?
Yes.
By restriction, I can use it. When I get to 13 pi over 6, that scares me.
No, it's
Straight
two.
on.
I think it's outside. It goes outside's bigger than this, isn't it? Even though it works, therefore I can accept only two answers, and those answers are 5 or 6, 7, 5 or 6. Okay. June, just quickly, if I'm gonna check 7, 5 or 6 with your help. If I replace theta by 7, 5 or 6, or a little check, that's 2 times this, which I think gives me 7, 5 or 3. Would you find cosine of 7, 5 or 3 and see what the value is? Just regular cosine, 7, 5 or
1/2.
3. 1/2. Checks. Okay. So Bill, the reason I place it on the handout, sometimes they do not give you a restriction, and you write up like, where was it? Oh, over here. That picks up all of them. General source. Sometimes though, like Rita just told me, sometimes they'll tell you restrictions. You just list those that are in this restriction. Okay? Madness. Okay, do we have any more than that? Whoa. I won't run out of time here shortly. Look through and see if there's one that has a square in it somewhere. Oh, there it is. Oh, 2 of them. Okay, name the first one.
2 sine square theta
Okay.
minus 3 sine theta plus 1 cosine
Plus 1.
plus 1 cosine.
Did I put anything on the side there?
Yes, from 0 to
To-
included to 2 pi not included.
Okay, it's the same thing you gave me earlier, except I placed it in interval notation. So they want only the answers that fall between 0 and 2 pi, like this one. Okay. Now, you guys tell me as I finish this one, this will be the last one I work in this section for right now. What do you think it's calling for? Let u be something. I bet this is a quadratic. I bet I get to factor or use quadratic formula. What would you suggest I let u be to rewrite it so I can deal with it? I heard sine. Hang on. If I do, guys, does this become immediately 2u squared? The first term. Then subtract 3u plus 1 is equal to 0. Now you've just taken a complicated trig problem into a middle school problem. I hope it factors. 2u, u, I think minus 1 and minus 1, we step back and look at it. You guys agree? I think it is, isn't it? Or you can use quadratic formula. Split these up, we know what to do now. This becomes u is equal to 1/2, and this is u is equal to 1. Use a weight professor, they want sine, so I know what u was representing, so this says sine theta equals 1/2 sine theta is equal to 1. Notice I keep taking you back to the unit circle, because there are no calculators when you finally see these. Now, can someone tell me on the unit circle, where have you seen the y coordinate? Sine equal to a 1/2.
5 or 6.
Definitely, that's, hang on now, 5 or 6. Karina, you said I can accept anything caught between 0 and 360, so that's good, there must be more.
12,
What else have you seen where sine is 1/2 besides 5 or 6?
5 or 6.
5, 5, or 6, quadrant 2. Can you list anything else before I leave that one where sine is positive 1/2? Some students may try 7, 5, or 6. What's wrong with 7, 5, or 6?
It's gonna be negative.
I think sine is negative on your unit circle down there. And 11, 5, or 6, I think it's negative again. So they want positive here. So we've got 2 of them. Now this one, I think, if I'm not mistaken, there's only one answer. Where have you seen sine, the y coordinate on the unit circle, equal to a 1? 5 or 2. 90 degrees is the only spot where you have seen the y coordinate to be a 1. And those are my answers. 5 or 6, I 5/6, pi over 2. That would be it. Now, you guys, with those few examples, and I'm sure there's more exercises there to work, right? I've worked enough. Do you sort of get the idea of what's going on here? You got solve an equation, solve an equation, solve an equation. Okay? Now, I want to say a few things about your quiz before I leave today. Quiz tomorrow. But, Arena, go to the next section. What section is next? Go to 6.4 and tell me at least what is one odd. And we'll try one there, then I'm going to stop. Oh, hang on. Hang on. Six point four. Okay, trig identity. And what did they ask you to do in number one?
Establish each item.
Establish. Not solve. Establish. And what's the first one look like?
Secant theta times sine theta equals tangent.
Sine theta is equal to tangent. You guys, this is a good, happy place to stop. They want you, not solve it, the word's not solve, establish. In other words, they want you to show that one side is equivalent to the other side, even though at this point they certainly do not look alike. And tell me how to do it. You're going to change secant into 1 over what? Cosine? And I think he wants me to leave that sign the way it is right now. Is it true? Here we go. And he says, Professor, you have now sine over cosine. Can I say directly that's equal to tan? So is this tan, guys? I'm going to put it right here. Confirm. And that makes the two sides the same. Yes or no? Now, how many students would love for your final exam? Wouldn't you love lots of these? You would, wouldn't you? Wouldn't you just love lots of these? And it worked out so easy. Yeah, see smiles on faces that Thursday you take your final exam, you see one like that. You say, oh, professor, ooh, I like this class. And then what happens? Arena, tell me what the next one is.
Sine theta plus cosine theta is all in parentheses.
Oh, sine theta plus
Plus cosine
and,
in parentheses. Squared
whoa,
plus parentheses sine minus cosine.
hang on, theta. Minus,
Cosine theta squared equals
equal how much?
2.
2.
Well, it doesn't follow.
Oh. You're not trying to solve anything like I was solving earlier. No, you're just trying to show those two sides. Now, don't see me if you see me in the hallway, I might do an answer this. You walk up and say, Professor, what is sine plus cosine squared plus sine minus cosine squared, Professor? Come on, Professor. You're the professor. And you, of course, you're looking for an answer 2. As I stand there. Anyone, what would you show? It's 2. Anyone have an idea? Then I'll stop with this. I think I-
First one, sine squared plus 2
Oh,
sine.
hang on. Let's do this. I hear something. Tell me more.
Sine squared plus 2 sine, sine times cosine theta, and plus cosine squared.
Whoa, hang on. Put that in red. He has already expanded that for me.
And the second one.
He
Two
just
sine
multiplied that
plus-
out now. Is it true? So far? And now you're going to do the same thing on the next one, I think. Hang on.
The second coefficient will be with minus.
Down here.
Yes.
This one's finished.
Yes. Yes.
Okay, hang on. I got plus, I'll put in blue. Now he's going to expand this for me.
Sine squared
There you go, hang on. Okay.
minus 2 sine cosine.
Wow. cosine squared.
Yes.
Cosine squared.
And
Wow. That's the left-hand side. If I take a close look at the red and the blue, he expanded that for me perfectly. I think these two crazy terms drop out.
Yes. And we use the formula of 1.
Well, what term do I have some like terms remaining?
Sine
Well,
squared.
I have 2 sine squared, right? I put these together, that's 2 of them, and I think cosine squared put together, I have 2 of those. Yes or no?
Yes.
Well, of course. Now keep in mind, they want us to show that this is all equal to 2.
Yes.
Now what?
Because sine squared plus cosine squared.
Now take out the 2 first, back out the 2. And that takes me back to a basic trig identity, and sine squared plus cosine squared is always equal to what? 1. So it says 2 times 1 equals 2, and you now have to match up with what they want. That's section 6.4. No, I'm not going anymore today. I'm working hard today. No, 6.4. We got 6.5, and I think 6.6, we have 2 more sections in chapter 6. I can get those done, Wednesday. I can get those done before you quit, probably start chapter 7. Guys, it's moving fast. Now, before I give you a little review, what on earth, Professor, are you expecting us to know tomorrow on our last week? I know it's 4.4 and 4.5. Before I do though, anytime instructors are asked, do you want to teach winter session? Because all professors are, they like to take a break. Take a break. Do you want to teach summer session? That's another 6-week session. Some professors, I understand, you want to take a vacation, you relax, and you take 6 weeks off. Professors have that right to do that. Now when they ask Ramsey, you want to teach winter session? My name's first one on the list. First one on the list, Selena. How many years have you done this, Ramsey? 25 plus. 25 plus. Now why do you want those short winter sessions? I'd rather go off and take a cruise somewhere. I've taken cruises before, but I know where to take it. Why do you want to do this winter session? Gee, Marina, Phil, DK, why do you want those students there for 6 weeks? 5 days a week, Ramsey? 5 days a week? That's exactly what I want. I want to see my students every day. It may be hard on them, it may be hard on me, but I think the benefit's there. The benefit is there. You would not be talking about this until in the 16-week term. Probably, I'm gonna make a guess out of 16 weeks, trade, you're probably right into the 14th week. Somewhere in there, 13th, 14th week of the 16 weeks. Before you get there. About the time you get there, you've forgotten some of the other, in that longer term. Oh, I see the students every day. That's why I do that. Okay. Now, 4.4, can anyone remind me, because I know what the quiz looks like. I've already constructed the quiz. It's short, 2 points. Can anyone remind me in 4.4 before we leave today, what might be a topic that might be of concern?
Logs.
Okay, logs. Now, you say logs, here we go.
I'm not sure.
What type of a question could I ask you about logs? Properties? Yeah, product property, quotient property, hour property, definitely know the properties. I want to see a 10 out of 10 on all of this. This is your last quiz, by the way. Properties of logs, what else could I be asking you for in this short quiz? On logs. Yeah, I definitely will ask. I will ask you about this also, something else. I don't know. Who can think of it? Well, I don't think 4.4 or 4.5, I don't think they're solving equations yet. Yes. You better know how to find the domain of a log function. Now, I'm not gonna work it out for you. That means if I give you all the quiz tomorrow, which I will, something like this, let's say ln, let's make it a natural log. And all of a sudden you see, maybe this. And I ask you, what's allowed for the x? What's the domain? Who recalls the routine we use? Yeah, this always has to be inside here by definition. Greater than, not greater or equal to, just greater than 0. Now, I'm not going to finish up completely. In this case, you factor that x out. Make it look like that. And then use what? Sign analysis. True. To make sure you understand how to find the domain. Property of logs. Now this, guys, look at it. Just in case, you may have to sketch. Maybe something crazy like this. See if I can make one up here right quickly. Maybe something like that. And we have to go through transformations. I think that's also in that 4.4, 4.4, 4.5. Now, I'm not saying, this is some topics, but you need to look at 4.4 and 4.5 and be ready. These are just off the top of my head, I thought of those. Now, if you want to join me tomorrow at, 11:30, I'll be glad to work these. Anything else? Get you ready for this last week. We okay? We're not quite ready yet. I think we're gonna meet my time. I think it's every second. Yeah.
Would we maybe need to find an inverse with a logarithmic function?
Oh, whoa. Was that in if it's in 4.4 or 4.5, is it in one of those sections? It is. Hang on. Let's try one. Do you have one handy there we look at?
Yeah, f of x equals 2 minus log of base 3 x plus 1.
Like this?
Yeah.
Like that?
Yeah.
Oh, you know what, let's do it. I'm gonna do this one. And I will tell you ahead of time, Joseph, I'll tell you it's 1-to-1. Don't worry about it not being 1-to-1. I'll tell you in my directions, it's 1-to-1, so there is an inverse. Now to find it, you're going to interchange first and rewrite it and get partial credit just to show me this. Oh, I'm glad you brought this up. Y plus 1. That's not going to do that. So you guys make sure I've interchanged. And then the next step, out of the 2 step, is now what? Solve for y. Now, can anyone tell me, be clever, you gotta get this by itself. Can anyone tell me the approach I can take at least to get started there, Joseph? Tell me again? Move the 2 to the other side. It's practical. Mathematicians in this class. Tell me more. I get the y by itself. Hope you tried a student, you're trying to solve this problem. Just trying to.
Main power of x.
No, not yet. I see something that bothers me. That bothers me. Multiply both sides by negative, or divide by negative. Well, the step 3, well, guys, if I multiply both sides by negative, we'll write like this just so you understand what I did. Of course, now the other side now looks like this. And the Rena, I think we'll get to you here in a second. Now, at least that negative side is gone, that bothered me. Multiply both sides by negative. Now, the critical part, now I think is what she's going to tell me. What's the critical part there? 3 raised to a power of? 2 minus x, or negative x plus 2 either way. Look at that.
And do we need to put the restriction y plus 1 is not equal minus 1?
Yeah, hang on. Okay? Now the word log's gone. She translated for me into an exponential. And to solve for y, you say, oh my goodness, professor, just move that 1 over. So it's 3 raised to this. Subtract 1 is equal to y is completely by itself, this is the inverse. Oh, I'm so glad you asked. Okay? Now, I don't know, I got a few minutes in, I see you're tired, I can see looks on your face like, whoo, Randy, you wore us out today. What's the domain on the original function?
X is not equal to minus.
Yeah, this inside here must be what, greater than 0? So x must be greater than what? -1. What part does that play down on the inverse? That's its range. They interchange it. If you want to put the range of the inverse down here, it's y is greater than -1. Domain here, inverse there. Domain range there. Yeah. Boy. Ugh. It might get tricky. Does anyone know the range of the original? Or
Is the
can come up
domain-
with the domain of the inverse?
Is the domain.
You know, it might be easier to look at this one and find its domain. If you can find its domain, that's the range of this one. Does anyone
Yeah.
think they see this answer here? Is there a restriction of any sort? Is there any restriction? I don't think so, is there? It says replace x by, can I replace x by any number I wish? Up here in the exponent? I don't see a log involved here. Is that true, guys? So it looks like right quickly, I'd say what, the domain down here was open? If that's true, then the range up here is open. That's the way it works. Now you got the domain and the range on function and its inverse. Wow. Okay. So guys, just be ready. Thank you for that. 4.4 and 4.5. Okay. Now do check your Canvas. I put the scores in that Mr. Park gave me. You looked at what you gave. By the way, guys, I got the papers, but I think we'll just wait until you pick up your quiz tomorrow. Unless you want to look at it now. I have your extra credit papers here. But let's just pick them up tomorrow when you do your quiz. Any questions, guys?